You can get in your car this morning, press a pedal, and hit 70 miles an hour without flexing a single muscle. 100,000 years ago, covering that same distance meant walking barefoot for 2 days straight through a wilderness that actively wanted to kill you. Today, movement is so frictionless, it's practically invisible. But for roughly 300,000 years, every single journey a human ever took happened at walking speed. That one biological limitation dictated what we ate, who we met, and how much of the world we were able to see. As an engine, the human body is a marvel of endurance. We are terrible sprinters, but we are engineered to never stop. Your feet have arches that act as springs, and your Achilles tendon stores and releases energy with every step to relieve your muscles. We also have 2 million sweat glands keeping us cool, allowing early humans to walk 20 miles a day, day after day, while every other predator on the savanna would overheat and collapse.
In 1978, Mary Leakey found physical proof of how old this system is. She uncovered a trail of footprints pressed into volcanic ash in Tanzania. They were made by 2 individuals walking upright 3.6 million years ago, and they look nearly identical to yours. This map shows the sheer scale of what that biological engine achieved. Starting roughly 70,000 years ago, small groups pushed outward from Africa, eventually covering 15,000 miles all the way down through the Americas. These journeys were intentional networking missions. Archaeologists have found obsidian and amber traded across hundreds of miles of mountain ranges. Walking was our very first global network. Walking works perfectly until you run out of land. For hundreds of thousands of years, a river or an open ocean was an absolute wall. It severed trade routes and stopped migrations. You either found a shallow place to cross or you turned around. Then humans did something no other land mammal has ever done. In Indonesia, on the island of Flores, archaeologists found stone tools dating back 800,000 years. Flores was separated from the nearest land by at least 12 miles of open ocean, even during the lowest Ice Age sea levels. Whatever wooden craft they built is long gone, but the tools are physical proof that a crossing happened. About 65,000 years ago, people pushed this even further, crossing at least 60 miles of open water to reach Australia. You cannot see the Australian coastline from the starting shore. Someone built a vessel, pointed it toward the horizon, and paddled away from solid ground without knowing if anything was out there. Eventually, Polynesian navigators scaled this up to cross the largest body of water on Earth. Around 3,000 years ago, they loaded families and animals onto double-hulled canoes and sailed the Pacific. Without a compass or a map, they read the stars, the direction of ocean swells, and the color of clouds to navigate open-water voyages over 2,000 miles long. Human biomechanics conquered the land, but the invention of the boat inverted the geography of the planet. We took the very things that acted as impassable barriers and turned them into highways. Even with boats for the water and legs for the land, early humans faced a massive physical bottleneck: weight. Your body can realistically carry 40 to 60 pounds over a long distance before your joints and muscles start breaking down. That severely limits how much food or material you can move between camps. To bypass this, early engineers invented the travois. By tying 2 long poles together in a V shape and slinging a platform between them, you drag the narrow end and let the wide end carry the load. This simple distribution of weight meant a single person could haul 100 pounds or more. Around 15,000 years ago, humans began outsourcing this muscular effort to other species. After domesticating dogs, we put them to work pulling sleds across the Arctic ice. A team of 6 dogs could haul an entire family's camp, moving weight that would have previously required a dozen people. By transferring the burden of weight from our own spines to wooden tools and animal companions, human societies expanded their resource capacity. We could transport more food, carry more materials, and build heavier, semi-permanent settlements. Dogs were strong, but humans needed speed. On the steppes of Central Asia, roughly 5,500 years ago, humans learned to ride the horse. Our top travel speed jumped from a 4-mile-an-hour walk to 30 miles an hour. Distances that once took weeks were covered in days, shrinking the human world by a factor of 8. Here is the paradox. Human beings successfully navigated the Pacific Ocean, mapped continents on foot, and tamed the horse long before anyone figured out the wheel for transportation. The oldest known wheels are only about 5,200 years old, and they started as spinning discs used by cotters to shape clay. Those early solid wood wheels were heavy and shattered easily on rough ground. But around 2000 BC, an engineer replaced the solid disc with spokes. This lighter, stronger design carried heavy cargo at high speeds. When attached to a chariot, powered by a horse, and run across paved city roads, you get a highly efficient transportation network. This combination of animal power and rotational mechanics allowed for the rapid movement of armies, the explosion of long-distance trade, and the administration of territories spanning thousands of miles. Across Eurasia and North Africa, these technologies became the logistical backbone of the world's first great empires. Today, you sit in a pressurized cabin, reading a newspaper while flying 3,000 miles across an ocean in a matter of hours. The physical struggle of movement has been entirely erased from the human experience. But the infrastructure we take for granted exists because of the ancestors who preceded us. Every paved highway, every global shipping lane, and every commercial flight path is all here because 300,000 years ago, someone looked out at the distant horizon, took a breath, and started walking.